Question 4, there's a few different ways that you can solve this one. This is the way that makes the most sense to me, but there are other ways, right? Okay, so we've got that resistance and that power. So in resistor 1, okay, at the moment the switch is open. Okay, so in resistor 1 we know that we've got a resistance of 2 ohms, and we know that we've got a power dissipated of 18 watts, right? So what can we calculate from that? Well, in my mind, it makes sense to link those two things together through this equation, P equals I squared R, which will allow us to calculate the current flowing in R1, right? So that's 18 equals I squared divided times by 2. Okay, so I squared is 9. Okay, so I is 3 amps, right? So that means that you've got 3 amps flowing there, which means you've got 3 amps flowing there and 3 amps flowing there. All right. Now that's helpful because it's going to allow me to calculate the EMF of the cell. Okay. If I've got 3 amps flowing through 2 ohms, then that using V equals IR, that's going to allow me to realise that that's 6 volts there, that's 6 volts there. Okay, and importantly, this is the bit that I'm trying to get to, 12 volts there. Of course, the other way that you can think of it is it's got the circuit at the moment, it's got a total resistance of 4 ohms, and 4 ohms times by 3 amps gets you the 12 volts, right? Okay, now things are going to change because we are now going to close that switch. All right, let's see how that affects the circuit when we close the switch. So now we've got this part of the circuit here forms a parallel resistor network. On an earlier video I said that if you've got 2 identical resistors and they're in parallel with each other, then the total resistance of this part of the circuit here, okay, is just going to be equal to half of either of the resistors, right? So the resistor, that resistor network now has got 1 ohm across it. The law of potential dividers says that the potential difference is proportional to the resistance. So that means that this resistor here now is going to get 2/3 of the share. All right. So now that's got 8 volts across it. Okay. And this has got 1/3 of the share, which is 4 volts across there. All right. We're nearly there. So now we've got a voltage and we've got a resistance, so we can use a different formula to calculate the power. We can use P equals V squared over R. Okay, and the voltage across resistor 1 is 4, and the resistance is 2, and that gets me 16 on the top, 2 on the bottom, so that's going to be 8 watts, which is answer A.